been seeing your contribution and being very active in the Gen AI community, the generative AI community. So one question that is lingering in the minds of everyone, who is involved in this and watching this transition from the deep learning to the generative AI, is this whole new battle between proprietary black box opaque Gen AI models versus open source LLMs. So what's your view on that, and particularly applying your context of working with NetApp, Google, and having been in the forefront of open sourcing Kubernetes? How do you see this whole thing?
Yeah, so just in terms of my context, I joined PearVC last year in November to work on, our enterprise investments. So PearVC is a very broad investment firm. It's the leading seed, pre-seed stage investment firm in the country, and it has one of the largest pre-seed seed stage funds. It's a $400 million fund that we are investing out of. By the way, you were talking about that excitement going to the first KubeCon. I get to experience that excitement on a near daily basis with the startups that I work with. So this is why I moved. But when I moved, it wasn't clear that I would spend so much time on AI. I had actually thought that I would have a lot of DevOps. At the time, I was working on secure software supply chain and DevOps, and I thought I would have a lot of companies, startups that would be doing work in that area. And it's true, there's some. But what happened in October of last year or November of last year is that OpenAI came out with ChatGPT, and suddenly that interface, changed the level of adoption, amongst the general audience of generative AI. And that's because I think they did a few things right by doing that RLHF, reinforcement learning with human feedback, by really aligning their model to what humans would accept in terms of conversation. And I think as they ran ChatGPT, they really took a lot of feedback from those conversations and incorporated it back into the model, making it better. And that was the sort of the opening of the Pandora's box, where it became clear that actually, AI is capable of a lot more than what the world thought it was capable of. And just to go back to my experience at Google, when I started in 2013, remember I was building chatbots, and my team was working on feedback clustering and sentiment analysis back in the day, right? So these technologies are actually, they've been in progress. People have been working on them inside companies like Facebook and Google and also Microsoft for a number of years, and of course OpenAI. So these capabilities have been around, but the unlock of really making them available in a way that they could generate either code or text or conversation, that they could generate those things in a safe way that was accurate enough to be consumed. This is a work in progress still. It's not done. It's a work in progress. But there was a breakthrough that happened. And it was a breakthrough that wasn't just a contribution of OpenAI. And maybe not everybody realizes that. That breakthrough has come through really, really actually open contributions that many folks have made, both in the open source as well as from a research perspective. A lot of work was done at Google and then contributed through research papers. A lot of work was done at DeepMind. This idea of RLHF is something that the folks at DeepMind worked on. The underlying technology of transformers is something that came out of Google and Stanford together, but really a major contribution from Google. Google open sourced this initial model called BERT, which is sort of the initial model that had a lot of these technologies. And then, of course, OpenAI at the time was also more of an open organization in terms of research contributions. The GPT models so generative, pre-trained transformer, which is just taking the decoder part of the transformer and then using it to generate text and language. That is something that they published quite openly for GPT-1, 2, and even GPT-3, kind of how did they train the model? What is the data set that they use? A lot of the data sets are open data sets. So this capability didn't come out of, closed research. It came out of the contributions of many. So I think going forward, I believe that it's important to maintain that. I think it's important for there to be sharing of the findings, because this technology is so impactful. It is going to have just, again, thinking back to year 2000 when I was, at Stanford, the effect of the web technologies at the time, you saw it really kind of play out over the next 5 years. And big companies like Google were founded, as a result of some of the developments. And of course, Google contributed a lot of those developments. Not all of those developments came out into the open right away. It takes many years for some of those developments to come out into the open. Like Kubernetes, for example, we worked on Borg, but it was many years later that we contributed. So I do understand the commercial impetus. I do understand why OpenAI sort of closed, their GPT-4 model. This is so advanced, and a lot of investment went into developing something like GPT-4. And I understand kind of what Google is doing with Palm and so on. So there are commercial objectives involved, and so it's not 100% open source, but companies like Meta and Hugging Face, and also the folks at Stanford. I'm collaborating very closely with the folks at Stanford right now. They are bringing out open source alternatives, and there's a whole, research movement that's happening. It's important. It's important because customers and users want to be able to introspect the software to understand, well, what went into this software. And it's also important for the further development of the field itself. It's important for next generation of researchers to be able to build upon what was done previously, for us to know, okay, how exactly did this RLHF work? What was the data set that was involved in training some of these large language models? So to the extent that that can be shared over time, even by these commercial entities, I think it will benefit. But in the meantime, many other folks, including at the Linux Foundation, are working on, kind of making these data sets open and putting a level of reliability against them, making sure that it's legal and is regulated to use this data in training these models. And then again, I always believe that it's important for mainstream enterprise adoption. And for mainstream enterprise adoption, it's important that these models be able to be used in a private context, so that an enterprise can take a model and run it inside its own data center, potentially on-prem, or in the cloud inside its own VPC, and to be able to fine-tune and retrain that model with its own proprietary data without feeding that data into some sort of central service. So that's going to enable use cases in healthcare, in law, in enterprises in financial services who need that level of privacy and assurance. And then that's where I think these open source models really come into play. So there are techniques right now in development where you can take an open source model, which is a much smaller model, can be put into your private environment, and fine tune it on your data and get it to run reasonably well. Maybe not, at general tasks as well as GPT-4, but at your specific tasks, whether it's, in a healthcare setting or in a legal setting, to provide advice to the lawyer, or to provide advice to the doctor, to really kind of make them more productive, take out a lot of the grunt work from some of these jobs. That is something that is going to be based on open source models, and those open source models are going to get more effective because of the commercial flywheel here.